Welcome back to Biofuels and Fuel Cells. After the first chapter, where we have seen all the kind of biofuels that we can use, let's go to system integration when it comes to use fuel cells. So we have both liquid and gaseous biofuels. Among the most important ones, we may mention hydrocarbons, bio-oils, bioethanol, producer gas, and biogas. All of them are suitable to feed fuel cells. However, some intermediate steps are necessary when it comes to system integration. Biofuels may have a variable composition, both in terms of bulk components and trace contaminants. For that, a fuel preprocessing unit is necessary in between the feeding source and the fuel cells that use the fuel. After that, another issue to address is the heat management. Fuel cell may be low temperature, like polymer electrolyte membranes, or high temperature fuel cell, for example, solid oxide fuel cell. These will change a lot the way components are integrated and balanced in a system. So let's have a deeper insight about the fuel preprocessing stage. So the main mission of that is remove harmful compounds that may occur in all of the biofuels that we have mentioned before, but also to yield a hydrogen-rich gas that is more efficient in the fuel cell downstream. So the first step in the fuel preprocessing line is cleaning. This will address sulfur compounds, halides and tars, and so on, according to the biofuels that we are considering in the specific application. Then we have gas conditioning. That is the operation needed to adjust the moisture content and the physical state of the gas. We may need to evaporate bioethanol, for example, and this would be an operation done within the gas conditioning stage. After that, we have a final operation, that is gas conversion and alteration. These include chemical processes like catalytic partial oxidation, steam or dry reforming, autothermal reforming, or water-gas shift reaction. All these processes are meant to yield a very high hydrogen-rich gas, or to remove all other gas components different from hydrogen if we have a specific kind of fuel cell that is just tolerant to hydrogen. So there are many applications in the market regarding biofuels and fuel cells. They range from mobile to stationary. In this slide we see some example of mobile application. So we may use biofuels to feed the polymer electrolyte membrane fuel cell engine that is housed in fuel cell vehicles. And in order to achieve that, we need to transform our biofuel into hydrogen, so we will need all the steps in the fuel preprocessing line, from cleaning to gas alteration. If we have other applications based on other fuel cell technologies, for instance, APU based on solid oxide fuel cell, it will be needed a milder fuel pretreatment. So still we can use all the biofuels we have mentioned before to feed this application for mobile vehicles. Then going to stationary application, again all biofuels are theoretically usable. So we may use biogas, producer gas, bioethanol, or other biohydrocarbons to feed, for instance, solid oxide fuel cell cogeneration unit. This is pretty state of the art. If we want to look at big plants existing right now, the most used biofuels is biogas. So we have example based on low temperature fuel cell. So before the fuel cell itself, the plant has other components aimed at cleaning and reforming biogas. So hydrogen is just fed to the polymer electrolyte membrane fuel cell, Or we have example of high temperature fuel cell application, most on solid oxide fuel cell technology, still based on biogas conversion. The same fuel may be used as an alternative to natural gas, also in molten carbonate fuel cell, that is one of the most affirmed technologies among the fuel cells.